Alright guys, welcome to the second part of the first of applications that we'll be doing. Remember, we'll be doing, I believe it's two applications, so one this week and one next week. This week we're focusing on standard deviations and distribution of data. Just a quick recap of what we did last lesson, which was the idea that when your bell curve is organized like this, or if you have a set of data that is organized like this, the data can actually be split into certain sections to represent what's happening and how much your data deviates from the mean. So if we look at a typical bell curve, the middle line here, or the peak is the mean. And remember that the mean looks like this little funny U shape. Okay, and then standard deviation basically is how much the rest of the data deviates from the mean. So one standard deviation from the mean, whether you go below or above, okay, represents 68% of the data. So 68% of your data is within one standard deviation from the mean. Okay. At two standard deviations from the data, so if there's the middle, two standard deviations, so represent that with the reds, will represent 95% of your data. Okay, so two standard deviations represents 95% of your data, and three standard deviations from the middle, okay, will represent, let's do that one better, will represent 99.7% of your data. So two standard deviations, three, my bad. Oops. Three standard deviations will represent 99.7% of your data. Okay. Now, before I forget, your standard deviation symbol, let me just scroll down a bit. So the standard deviation symbol looks like a little circle with a little line on top. So that's the standard deviation symbol. You'll be seeing that a lot more in this lesson. So that's the standard deviation symbol. Okay, remember, so the idea behind this is understanding how far from the mean your data is distributed. The next part of this is going to be understanding how far from the mean certain data is distributed. Okay, and that's what a standard z-score is. Okay, so as it says here, to find a comparison between scores in a particular distribution, we use a z-score. So the z-score is also called a standardized score, and it indicates the position. So that's the interesting here, most important thing here, is the position of a certain score in relation to the mean. So again, looking back at this distribution, a z-score determines how far from the mean a certain number or value is. Okay, and hence why I did mention that this bell curve is very useful for teachers, because it gives us an indication of where you are at in relation to the rest of the class. Now, we use a formula to calculate the z-score, and it looks like this. Okay, this is your standard z-score formula, where it says z equals x refers to the score, or the value that we're looking at, so the result, minus the mean, divide that by the standard deviation of the actual data. Okay, so the standard deviation determines, again, remember, how far, so one standard deviation would relate to, so for example, if you have a graph like this, standard deviation is one standard deviation, right? But that one standard deviation could be like 2 points, 3 points, or it could be like 4 grams or 5 grams. Okay, so just make a note of that. If you've done the exercises previously, you'll understand what that means, but let's keep going. So in the z-score formula, x represents the actual score, that u, remember, represents the mean, and then the O with a little thing on the top will represent the standard deviation, okay, of the whole data. All right, let's do an example of it. In an IQ test, the mean score is 100. Okay, so in a typical IQ test, the mean score is 100, and the standard deviation is 15. Okay, Dale's test results give an IQ of 130. What is his z-score? So let's calculate his z-score. So remember, the formula for a z-score is the mean, or sorry, the score that that individual got, or that result for that certain item. Take away the mean. So the score minus the mean divided by the standard deviation. I'll put that in brackets for now. Score minus mean divided by the standard deviation. So in this case, for Dale's score, his z-score would be 130. So his IQ score was 130. Okay, take away the mean, which is 100. Actually, just green. The mean of 100, right there. So take away 100, minus 100, and then divided by the standard deviation. And according to this, the standard deviation is 15. All right, so you put that in your calculator. 130 divided by, minus 100. And remember, just make sure that you put these in brackets, because if you just put straight up divided by the standard deviation there, just think about how BODMAS works. Yeah, it's going to actually work out 100 divided by 15. So it's all of this divided by 15, and the score is 2. So that means Dale's standard deviation, z-score, is 2. Which means, so if his z-score is 2, that means he is 2 standard deviations above the typical 100 IQ. So if you were to represent that in here, and the mean, the middle is 100, Dale's score would be 2 standard deviations above the mean. So he's actually maybe around here. Okay, he would be 2 standard deviations. His result in relation to the bell curve, he'd actually look pretty smart because his score is 130. Okay, as opposed to the mean of 100, which is the typical of what everyone gets. All right, let's move on. So comparing, actually, yeah, let's move on. Maybe we can do, let's do one more example just to hit it home. So let's say, for example, I'm gonna make my own example in relation to you guys, and yeah, how you, I guess for you as a class, and yeah, see how this works. So Todio's maths class, let's make up an example, scored, has a mean score of, let's say, 70%. Okay, one standard deviation from this is 5%. And let's say, for example, Blake scored, let's say 67% on his SAC. Okay, what is his Z-score? Okay, so let's figure out Blake's position, or Z-score, in relation to the rest of the class, right? So we're going to use this, okay, to make sure we understand how this works. All right, so let's calculate his Z-score for now. So Blake's Z-score, remember the formula is whatever his score was, take away the mean, divided by the standard deviation. Okay, so in this case, Blake's score was 67%, so 67 minus the mean of the class was 70%. Okay, and then the one standard deviation is 5%, so standard deviation there is 5. So what is his Z-score? 67 minus 70 divided by 5. 67, take away 70. I should put brackets on that. Divided by 5. So that means Blake's score, standard deviation, his Z-score is negative 0.6. Okay, now, how does that relate to this? Let's make sense of it. So, remember that on this graph, okay, according to my information here, the mean was 70%. So, right here in the middle is 70. Okay. And one standard deviation above and below is 5% according to this information. So that means we can go up by 5s on this. So that's 75, 80, 85, and this is 65, 60, and then 55. Now, according to this, Blake got a Z-score of 0.6, so that means he is 0.6 away from the 0.6 of a standard deviation away from the mean. So if that is the case, Blake's Z-score would mean that his position would be somewhere around here, 0.6. So if this is halfway, 0.5, 0.6. So 0.6 of a standard deviation would be here. This is where Blake's score would be. Okay. Remember, he got a 68%, right? Sorry, 67% as his score. So his standard deviation determines that his position will be right here with the rest of the class. So he's a little bit below the average. Not saying that you are, Blake. This is just an example. Okay, so let's move on. Comparing data. So in this case, in this scenario, Janine scored 82 in her physics exam and 78 in her chem exam. In physics, the mean is 62 and the standard deviation is 10. In chemistry, the mean is 66 and the standard deviation is 5. Write both results as a standardized score. Which is a better result? Explain your answer. Okay, so obviously here what you're looking for is which one has the higher Z-score. So the better the Z-score in the positive, the higher Z-score in the positive side, the better. Alright, so let's figure out what her Z-score was. Remember, the formula for the Z-score is the score take away the mean over the standard deviation. Okay, so the score minus the mean over standard deviation. So let's work it out first for, she had 2 exams, yeah, so let's do physics. So in physics, she scored 82. That's going to be 82 take away, and the mean for physics is 62 divided by the standard deviation, which equals 20 over 10, and that means her Z-score for physics was 2. Okay, easy enough. Let's do now for chem. So in chem, her score was 78. Take away the mean of 66 divided by 5. So that means her Z-score, which equals, what's that, 78 minus 66, which is 12 over 5. So her Z-score would be 2.1. Oh no, sorry, 2.2. Okay, so there is her Z-scores. Now, looking at this, which is the better result? Explain your answer. Now, when it comes to this, which is a better result, we're looking for the highest Z-score, because these scores, okay, or her scores here, 82 and 78. Yes, physics looks higher than chem, but in relation to the rest of the class, her Z-score states that she was 2.2 deviations higher than the rest of the class, whereas in physics, she's only 2 standard deviations higher than the rest of the class. So for part B, you could actually state that the better result was actually chem. Okay, because she was 2.2 standard deviations higher than the rest of the class. So because Z-score is higher, which is 2.2. So that states that she's 2.2 standard devs above the rest of the class. And that's basically it for this lesson. So I hope that's made sense to you guys. Go ahead and complete the rest of the questions here. So that would be 7 to 21. I will go ahead and unblock these yellow things. But thanks, guys.